The next video that we're going to talk about is going to be a video that kind of goes hand in hand with what we talked about in class. So in class, we talked about the basics of functions, things like domain and range, things like piecewise functions, how to evaluate functions, things like that. So the next lesson kind of talks about the different aspects of a function. So one of the things we're going to talk specifically about is domain and range. So one of the reasons that I taught you about interval notation in the last unit was because that's how we're going to express our domain and range for the most part. Now, things to remember: domain is all of my possible x values, and my range is all my possible y values. So another way to look at that is that your domain is looking left and right on your graph, and your range values is looking up and down on your graph. So in my graph here, notice that my graph doesn't go on left and right forever. It actually starts at the x value of -2 and then continues on through all the x values all the way until you get to an x value of 5. So if I was going to state a domain, I would show that any x value between -2 and +5 are in play, and then I would include -2 because it's a closed dot, and I would exclude 5 because it's an open dot. If I was talking about the range of my graph, I'm looking now up and down. So what's the very lowest y value and what's the very highest x value? The very lowest y value is down here at -2, and the very highest y value is way up here at 7. So all of my y values in between -2 and 7 are in play, and notice that I touch both of those y values, and that's why they're both included. Not only can we determine a domain by looking at a graph, but we can also figure out a domain by just looking at an equation. And what we're looking and asking ourselves the question is, what x values can I put into my equation and it would spit out a y value? So looking at this one, this equation, this function is called a polynomial. And what we're going to learn is that polynomials don't have any restrictions on their domain, meaning that I can pick any x value I want and I can plug it in for x, and it's going to give me some kind of y value. Now, it may not be a y value you like. It may be a very large number or even a very small number, but you're going to get something. So we say the domain for our polynomial functions is all real numbers. That just means I can literally plug in anything. In the next function, we have a little bit of an issue, and it's one of these issues up here. So there's two things in algebra you can't do. You can't divide by 0, and you can't take the even root of a negative number. So the thing that's going to be an issue here is the divide by 0 stipulation. If I plug a particular x value in here, there's the potential that I could get 0 in the denominator. All we do to figure out what that number is take the denominator, set it equal to 0, and solve. So if I do that, I get an x value of -5. So when we state our domain, we say that x can be anything except -5. Now here's how we state all real numbers using a symbol. It's a giant double-backed R, so all real numbers except -5. So my slashed equal sign tells me that I can use anything except -5. Underneath the next one is a square root function. This last one was called a rational function, if you want to make note of that. Square root function. This has an issue because I can't take the even root of a negative number. So the kinds of numbers I can take the root of would be anything positive or 0. So all I care about is, when is the underneath portion bigger than 0 or equal to 0? So I'm going to take the underneath portion and set it greater than or equal to 0, and then find the values of x that make that true. This is a very easy inequality to solve. So all I'm going to do is add 6 to both sides, and I get x is greater than or equal to 6. That would be the inequality notation for the domain. If I wanted the interval notation for the domain, anything larger than 6 would look like that, 6 to infinity. We would include 6, exclude the infinity. So either one of those actually says the same thing. Last one here is called a cube root function. Now notice my two stipulations. Can't divide by 0, can't take the square root, fourth root, sixth root of a negative. That's not an issue in this problem because I have an odd root. It's a cube root. What you're going to find out about odd roots is that there are no restrictions, so it's just all real numbers. Keeping in mind that that double-backed R means all real numbers. Can literally pick any number you want and it's going to work. The next thing we're going to talk about is the concept of increasing and decreasing. So I've got this little picture here, and what we're talking about is if the ant is walking uphill, we would say that we're increasing. If the ant walks down the hill, we're talking decreasing. As he starts walking back up, he's increasing. If he's ever on a flat plateau, that's called a constant interval. Now, we always read graphs from left to right. So as I go from left to right, is the graph going up, down, staying the same? The other thing that we figure out is that our intervals are always expressed with x values. So it's the x values for which the curve is going up, down, or staying the same. So in number 1, if I read the graph from left to right, the graph is going up, goes down, goes up. So we've got an increase interval, we've got a decrease interval, and we've got an increase interval. So what we're going to do is express each of those intervals in interval notation. And here's how we're going to do it. Intervals are always x values, so from left to right. So the very left over here would be coming from negative infinity, and it stops increasing all the way when I get to the x value of negative 2. So from negative infinity to negative 2, it decreases for a little bit, and then it starts increasing again at an x value of 0. So from 0 to infinity, it continues to increase. Now, grouping symbols. The point where you stop increasing and start decreasing is called an inflection point. It's an instantaneous change, meaning that that point at negative 2 is not increasing and it's not decreasing. So that's why we're going to use open parentheses. You'll always use x values, and you'll always use open parentheses with increase and decrease. So you might want to make note of that. Always x values, always parentheses. The decrease interval, we start decreasing at an x value of negative 2, and we stop decreasing at an x value of 0. So from negative 2 to 0. In the next one, when we're looking from left to right, we have an increase interval, we have a constant interval, and we have a decrease interval. From left to right. So that increase starts at an x value of negative 9, because that's my x value here, negative 9. So from negative 9 all the way up until 1, 2, 3, 4, oops, looks like 3, an x value of 3. So from negative 9 to 3, we are increasing. We start a constant at 3, or negative 3, and we stop our constant at 1, 2, 3, 4. So from negative 3 to 4, we're constant. The last one is decrease. We start decreasing at 4, and we stop decreasing at 9. So from negative 4 to 9. And again, notice every interval uses parentheses because those points of change are instantaneous. That point there is neither increasing, decreasing, or constant. On the back, we're going to talk about the concept of minimum and maximum values. So minimum and max values are basically what they sound like. They're just humps and valleys in the graph. So any hump in the graph is a maximum. There's possibility that you could have more than one maximum in a graph. Some graphs have more than one hump. Any valley in the graph is called a minimum. There's possibility that you could have more than one minimum in a graph, depending on does it have multiple humps or multiple valleys. So what I've got here is kind of a picture that puts this all together. So we're going to talk about the domain, the range, any zeros, so where do I hit the x-axis, any maximum values, so any humps in the graph, and any minimum values, so any valleys in the graph. So let's talk about min and maxes because that's what we just discussed up here. So if you look, you've got two valleys. You've got one there and one there. So we just need to identify both of those coordinate points. This coordinate point here looks like it is 1, 2, 1, 2. So -2, -2. This one here is at 1, 2, 3, 4. So at 4, 0. So those are my two minimums. I've got one maximum, one hump in the graph at 1, 2, 1, 2, so at 2, 2. Zeros, where does the graph hit the x-axis? We hit the x-axis at 1, 2, 3, -4. We hit the x-axis at the origin, so at 0. We hit the x-axis at 1, 2, 3, 4, +4. Domain and range, so how far left and right does the graph go? Range, how far up and down does the graph go? So domain, as these branches go up, they're also continuing to go out. So they go up faster than they go out, but they do continue to go out forever. So we would say our domain here is all real numbers. These branches are never going to stop going left and right. The range, you're looking how far low and high the graph goes. So looking at the graph, the lowest y value would be here at this point. That value for the y's is at -2. And then these two branches are never going to stop going up. So we say that our range is a y value of -2 and up. So we would top out at +infinity. So there's domain, range, zeros, max values, and min values. The last thing we're going to talk about is even and odd functions, and this is actually something that I'm going to spend the first 10 minutes or so of class talking about because I think this is something you're going to want to ask questions about. So I'm just going to explain this the first 10 minutes of class or so. So make sure that you make note of any questions you have about the other topics. So finding the domain, whether from a graph or an equation, finding the range from a graph, finding the zeros of a graph, or finding the intervals of increase and decrease, or finding the min and max values, so any humps or valleys in the graph. Make note of those things, and we will discuss them in class. I'm not going to give you 5 problems to work on because doing this even and odd stuff is going to take up the that first chunk of class. So we'll talk about this stuff then, and any questions that you have with the other concepts.